Are you struggling to impress hiring managers with your web development portfolio? In this video, I'm going to show you how to stand out from the pack by adding a personalized interactive 3D avatar to your portfolio. By the end of this video, you'll learn how to create a personalized 3D avatar, add animations to it using Mixamo and Blender, and display your avatar on your portfolio using Three.js. As a bonus, I'll even show you how to make your avatar interactive, so when a user clicks on it, they get a special surprise. Now, there are several options to choose from when creating a personalized 3D avatar. The two that I found are Avaturn and Ready Player Me. In comparing the two, Avaturn has a more realistic looking avatar, while Ready Player Me is a bit more stylized and cartoonish. They both look great, so really it's whatever vibe you're going for. I'll be using Avaturn in this video. After creating a free account on Avaturn, I followed all of their instructions to create my avatar, which involved the simple process of taking 3 selfies and uploading them. Once that was done, my avatar was ready to be customized. After going through all of the options, I ended up with something that actually is kind of uncanny in how much it looks like me. Once I'd finished tweaking everything just right, I exported the model. I needed to log into their Discord and type /Avaturn in the Use Bot Here channel. Now this gave me a link that took me to where I could finally export my model. At the model export screen, I selected Avatar T-Pose, which then downloaded the GLB model to my computer. Once you have your model, it's time to pick out which animations you'll be using. Mixamo is a free service offered by Adobe that offers a variety of high-quality animations, which you can preview right in the browser. Now in order to get the Mixamo animations to work with our avatar, we first need to upload a character to Mixamo with the same skeleton as our avatar. Now this step is essential, otherwise we'll have issues applying the animations to our avatar later on in Blender. Now luckily, Avaturn has some great documentation on how to do this, and I'll link that in the description below. Once you've downloaded the model from Avaturn, upload it to Mixamo using the Upload Character button. After the character is uploaded, verify that everything in the auto-rigger works, and then click Next. Now the fun part, picking the animations. The default animation for my avatar will be a simple waving animation. And to add an extra bit of fun in, when a user clicks or taps on my avatar, I'll switch to a stumbling animation to make it seem like the user pushed me over. When you find an animation you like and you've tuned it to how you want it, press the download button. Now make sure the format is set to FBX, the skin is set to without skin, and I've set frames per second to 30 and keyframe reduction to none. Repeat the same process for your second animation. Now that we have our avatar and both of our animations, we're ready to combine them into a single file in Blender. Starting with a new scene in Blender, begin by deleting the default collection. Next, we'll import the 3D model of our avatar. Go to File, Import, GLTF 2.0. Locate your model and import it using the default settings. Start by enabling viewport shading to see your shaded and textured avatar. The avatar starts in the default T-pose since we haven't yet applied any animations. Rename the model to Avatar in the scene tree. Now we need to import our first animation. Go to File, Import, FBX, and locate your animation file. I'm starting with the waving animation. Import using the default settings. Next, let's hide the avatar so we can see the animation in action. By pressing the spacebar, it will animate the armature. The next step is binding the animation to our avatar. Open up the dope sheet and switch to the action editor. Then select your avatar in the scene tree. Browse the list of available actions. There should only be one, which is the animation you imported. Select the animation to apply it to the model, and then be sure to rename it to something that makes sense. In this case, we'll name it to waving. Now when we press play, we can see our avatar animate. In order to save multiple animations with our model, we'll need to save them as NLA strips, which stands for nonlinear animation. Go to the nonlinear animation panel and then locate the waving animation associated with the avatar and press the push down action button to add a new NLA strip. When you push the button, you can see that a new strip is created. Now we can go ahead and delete the armature associated with the armature that we imported. leaving us with our avatar, which now has the waving animation. We're ready to add our second animation. Import the second animation using the same method that we used for the first. In the nonlinear animation panel, rename our second animation to some sensible name, in this case stagger. Then under avatar, select the no action and then browse to the stagger animation. Once more, press the push down action button to create a second NLA strip, and then finally delete the armature associated with the imported animation. Now we're left with our 3D avatar that has both of our animations as separate tracks. You can check and uncheck each strip to play each individually and make sure that they're both working. Finally, export the model by going to File, Export, GLTF 2.0. Make sure that GLTF binary format, or GLB, is selected, and then under Include, check Active Scene. Finally, double check that Animations is also checked, then go ahead and export your file. Now that we have our 3D avatar model and our animations all exported to a single file, we're ready to start our coding. Now the template site that I'm going to be working off of is very simple here. I just have a navigation header at the top and then a content section which currently just has a single section in it. And here I have the title that says, "Hi there, I'm Dan Greenheck," and then just a little blurb that says, "I'm a web developer with a passion for creating interactive 3D web experiences." We need to get Three.js into our site, so the first thing that we'll need to do is add the Three.js dependencies. So in the head section of your site, you add the Three.js dependencies using this import map here. So we'll need to import the Three.js package, and we're also using some add-ons that come with Three.js, and we need to import that using the following line here. Now we need a place to store all the code that we're going to be writing, so I like to keep that all in a separate file. So in the file browser here, let's go to New File, and I'll create a new JavaScript file called avatar.js. So after creating our avatar file, we want to make sure that we're importing that file and running it when our site is loaded. So below where we created our import map here, we'll just add an additional script of type module, and we'll point that to our avatar.js file. So the final thing that we need to do before we start coding is to add our avatar.glb file that we exported from Blender. We want to add that under the public folder, and that way we can reference that later on when we're loading the model. So now we're ready to start writing some code. So in our avatar.js file, you'll start by importing the Three.js dependency here. The next import is importing the GLTF loader, and this is a class that we'll be using to load our GLB file. The final import is for orbit controls. These are a type of camera controls that comes with Three.js, and we can use this to rotate our model around and zoom in and out. Now in our HTML file, I've added two different divs at the top of our home section here. So the first div has an ID of avatar container. This is going to contain our 3D scene. And then the next div has an ID called avatar loading. So this is going to display the progress indicator as we're loading our model. Now the next thing that we'll define is our load model function. So in here we're creating a new instance of GLTF loader, and we're assigning that to the loader variable. You can see I'm specifying the path to my avatar.glb file here that's in the public folder. So this load method on our loader has 4 arguments. So the first is that path to our file. And there's 3 additional callback arguments. So going through these callbacks one at a time, the first one gets called when our model is completely loaded 100%. So the next callback is the progress callback. So this gets called frequently as the model is loaded. So we can use this to update a progress indicator on the site so the user knows that something is happening. They're not just waiting with a blank screen. And then finally, we have our error callback here. So any issues with the model loading process, we can catch them here and display it to the user if needed. So finally, we're going to make sure that we call our load model function when the window finishes loading. So I've just assigned window.onLoad to this method here. That we'll just call our load model function. So let's go ahead and implement each of these callback functions in our model loader function. So when our model is loaded, we want to go ahead and call the setup scene function. So we've yet to define this. We'll be doing that in just a moment. But we're going to pass in the loaded GLTF model. So I'm going to be using GLTF and GLB interchangeably. They're both really the same format, just that GLB is the binary version of that. Next, since our model has finished loading, we're going to get our avatar loading div, and we're going to set the display on that to none to hide that. On our progress update callback, we'll start by computing the % completion of the loading. So we can just take the loaded property of XHR and divide by the total and multiply by 100 to get the % that the model is loaded. And then we'll update our avatar loading text here, which is this element right here, and we'll update that with the loading %. And finally, we'll just print that to console as well, just for debugging. In the case of an error, we're just going to write the error to the console. We won't do any special handling for that in this video. So this is all the code that we need to load our 3D model. So let's go ahead and finish our setup scene function here so we can actually get our model displaying on the screen. In our setup scene function, we'll start by creating a new WebGL renderer. So this is going to be responsible for rendering our model to our HTML canvas. I'm also setting anti-alias to true to give our model some nice smooth edges, and setting alpha to true so that the background is transparent. Next, we need to set the output color space of our renderer to sRGB color space. So this is a new thing, I believe in version 152 of 3JS. So we just need to make sure that we set this explicitly so that the colors in our model show up correctly. The next step is setting the size and pixel ratio for the renderer. So you can see I'm starting by getting our avatar container element. So if I look in the DOM here, you can see within the home section, I have the avatar container. So I set the container to take up 50% of the height of the window and then take up the full width of the page. So this area highlighted in blue here is where our scene will be rendered. So we're getting that element, and then we're getting the width and the height of the element to set the size of the renderer. Then finally, we're setting the pixel ratio to the pixel ratio of our device so that the pixels are scaled correctly. I also went ahead and enabled shadows on a renderer. So all you have to do for that is to set enabled on shadow map to true. And I'm using PCF soft shadow map here for our shadow type. Now this is the best looking shadow. If you want to go for more performance, there are other shadow types that aren't quite as performance heavy. Finally, we want to take the DOM element associated with our renderer, which is an HTML canvas, and we're going to append that to our avatar container element. Now before we can get anything to render to the screen, there's a few more things we need to do. We need to set up a camera, we need to set up a lighting, and we need to create a scene that we can add our model to. So to start, I've defined a perspective camera here. So I give that a field of view of 45 degrees. And then we also need to specify the aspect ratio for the camera. So I'm taking the width of the container and dividing it by the height of the container. And then I'm setting the position of the camera. I've already kind of determined this ahead of time. This is just to make sure that the model is in view just right and the camera is at the right height. The next part of our camera setup is setting up the orbit controls. So this looks like a lot, but it's actually quite simple here. So first we set up our orbit controls and we pass in a reference to our camera and the DOM element associated with our renderer. Then I'm assigning that to the controls variable. Then I'm just setting some properties here in the controls to get the experience that I want. So enabling damping makes things really smooth as you're rotating around. There's some acceleration to it. I have disabled pan and zoom just because it kind of makes the experience confusing when the user's interacting with it. I've set the minimum camera distance to 3 just so the model is just far enough away from the camera. And then I've locked in the polar angle, so this is kind of the elevation of the camera, to 1.4 radians. Finally, I've set the target for the orbit controls to 0.75 on the y-axis, and this is to get, and I need this line so that our camera is looking at the correct spot in our avatar. Finally, I call controls.update to apply all of these changes. After we set up our camera and our orbit controls, let's go ahead and create a new variable called scene, and then create a new 3JS scene object here. So this is where I'm going to add all of our lights and our avatar to. So for the lighting setup, I'm just going to start with adding an ambient light. So this light doesn't have any direction. Every part of our avatar is going to be lit up equally. Now eventually we'll be adding some more lights in, but this will give us a good place to start from and make sure everything's working and that it's not due to any issues with our lighting. After we add our ambient light, let's go ahead and finally load our avatar here. So we'll get the scene property of our GLTF model that we passed in. So this contains the avatar mesh data. So to get shadows working properly, we need to traverse through all of the child meshes within our avatar and make sure that we set cast shadow and receive shadow to true. So we can utilize the 3JS traverse function here. So this just takes in a callback where the one argument is the child mesh. So we see if that child is a mesh, then we'll set cast shadow and receive shadow to true. Then finally, after we get the shadow set up properly, we'll go ahead and add that to our scene. Now we're not seeing anything rendered on our page yet. We still have to set up our animation function. So let's do that so we can finally see our model loaded. So finally we get our model loaded on our screen. And right now it's kind of stuck in the T-pose because we don't have any animations enabled yet. But let's see what code we needed to get this working. So all I did was create an animate function here. So the first thing that we need to do is request an animation frame from the browser. And then we pass in a reference to our animate function as a callback there. And then this is where all the magic happens here. We ask the renderer to render the scene from the perspective of the camera. Now to kick everything off, we need to call the animate function once, and then it'll take care of it from there on. So at the very bottom here, I'm calling the animate function. So now that our model is loading properly, this would be a good time to add some additional lighting to our scene. So I went ahead and added a spotlight here, so you can see things are already looking a bit better. There's some more contrast to our model. So in setting up our spotlight, there's 4 different parameters here. So the first is the color of the light, which I've set to white. Next is the intensity, which I've set to 20. The third argument is the maximum range of the light, which I've set to 8. And I've set the angle of the light to 1, just to give it kind of it's looking from top down, but it's also looking a bit forward. Then I've also set the penumbra, or kind of the size of the spotlight, the position of the spotlight, and also setting cast shadow to true, so it will cast shadows on our model. Finally, to fill everything out, I went ahead and added a directional light, which I've called key light. So this is a white light with intensity 2, and then I'm just setting the position of that light and having that look right at the origin. So right now my avatar is just kind of floating in space, so I'd like to have something for him to stand on. So I'm going to go ahead and create a little pedestal that's going to be right below his feet. So here's the code to create our pedestal. It's pretty simple. All we're doing is creating a new cylinder geometry. So I'm setting the radius of that to 0.6 for the top and the bottom radius, setting the height to 0.1, and the 64 is the number of sides or radial segments. So this just makes sure that the pedestal is really smooth around the edges. I'm using a default standard material for our pedestal material here, so nothing special there. Then I'm going ahead and creating a new mesh from that, passing in the geometry and the material. Finally, I'm setting the shadow properties on that, so I don't need my pedestal to cast shadows, so I'm disabling that. Setting a receive shadow to true, so you can see if I rotate the model here, we have some shadows kind of behind our avatar. And then I'm displacing the Y position just slightly below the avatar, so it looks like I'm standing on this pedestal here. And then finally, I am adding that to the scene. So we're finally at a point where we can start animating our avatar here. So let's walk through these lines and what each of them is doing. So first we're creating a new animation mixer. So this allows us to take multiple animation clips. So a clip is like the different tracks that we added in Blender. So I have a waving animation and a stumbling animation. So those are both different clips. And we can mix those different animations together to varying degrees to get smooth transitions between each animation. So after we create our mixer, I'm getting the clips or animation clips associated with our GLTF model that we loaded. and then I'm finding each of those clips. So if you remember back, I named my animation tracks waving and stagger. So I'm searching all of our animation clips and finding the clip that has each of those names. I'm storing them in wave clip and stumble clip respectively. Now once we found our clips, then we're going ahead and create actions associated with those clips. So we create actions by calling clip action on our mixer, and then we pass in the clip that we want. And actions allow us to kind of stop and start our animations, set whether the animation should be repeated or not, how it should blend between another animation. So in order to get our animations to work properly, we need to update our mixer each time we render a new frame. Gone ahead and created a new clock here. Then we're getting the delta, or the change in time between each animation frame. We're getting that from the clock, and then we're passing that into our mixer update method. So the final step to get our animation working is we need to take one of our actions here. So I'm starting with the wave action because that's my default action, and I'm calling play on that. Now, if you just want an avatar that performs a single animation, this is a great place to stop. I think this is pretty impressive what we have here, but I'd like to take it to the next level. Let's add some interactivity so when the user clicks on our avatar, it'll trigger that second animation and will cause the avatar to stumble. So there's one more function we have to write for that, so let's go ahead and do that. Now to add that interactivity, we're going to add an event listener to our container, and we're going to listen to the mouse down event. So if that event occurs, we're first going to compute the normalized device coordinates, which basically means we're taking the entire canvas that our renderer renders to, and we're mapping that between -1 and 1 in the x-axis and -1 and 1 in the y-axis. So we're taking the offset x and y position from the mouse and dividing it by the width and the height of the container. Then we multiply by these factors here to scale that between -1 and 1. So now if I click on my avatar, or anywhere within the renderer frame, you can see that it's computing those coordinates. Now in order to determine if the mouse is over our avatar, we need to use something called raycasting. So I'm creating a new raycaster object, and I'm assigning that to this variable here. So we'll see very quickly how we can use this to determine if our mouse click is intersecting our avatar. Now to begin the intersection process on our raycaster, I'm calling setFromCamera. So here we pass in those normalized device coordinates that I talked about. So the x and y components are between -1 and 1. And then we're passing in the camera so we know where to shoot out that ray from. So once we set up our raycaster, then we call intersect object on the raycaster. And we pass in our avatar mesh. So we're basically asking it to determine if there's an intersection between our mouse clicks and this avatar mesh. So that returns an array of intersections, and then we check to see if there's any intersections in that array. And if there is, then we'll print to the console the word intersection. So let me clear the console here. So if I click around the avatar, you can see nothing is being printed to the console. I can even click between my legs, and I'm not getting anything, but if I click on my head, you get an intersection printed out there. Let's clear that again. If I click on my leg, I can click on my arm. So anywhere I click on that avatar, it's going to log an intersection. Now I can even click on the pedestal here, and because I'm only checking against avatar, it's not going to register an intersection if I click on any other mesh in the scene. So I've replaced our console log statement with these 3 lines here. So what's going on here? First, for our stumble action, we're resetting it to the beginning. So it's going to play that animation from the very start. Then we're playing that animation, or playing the action, I should say. And then we are fading from the current action that we're playing, which is the wave action, to the stumble action. So I'm calling it crossfade to make that transition happen. And then this is the duration in seconds. So the time it'll take to transition from wave action to the stumble action will be 0.3 seconds. So if I click on my avatar now, I should expect my avatar to start stumbling. And we can see that happens, and the animation plays out, and then the animation keeps going, which is not really what we want. So we need to make sure that after a certain amount of time that we'll go back to the wave animation. So here I'm following this code with a set timeout. So what a set timeout will do is it'll execute in these 3 lines after this time period has expired. So this is 4,000 milliseconds or 4 seconds. So 4 seconds after we start our stumble action, then we'll transition back into the wave action. So it's a very similar process. Rather than resetting and playing the stumble action, we're now resetting and playing the wave action. And then we're fading back from the stumble action into the wave action. And I've set that to a transition time of 1 second just because it looks a bit more natural. So now if I click on my avatar, you can see that I stumble, and now it transitions back into the wave animation after 4 seconds. And that will keep continuing until I click on our avatar again. Now there is one issue that we have to work out. So if I click and then I click again, you can see that we get some kind of unexpected behavior here. So we want to prevent the user from triggering the stumble animation again if the avatar is already stumbling, and that'll prevent that weird issue where it's going back to the T-pose. So right above our event listener where we're defining the raycaster here, I've added a new variable called isStumbling. So we'll initiate that to false. Now, if we detect an intersection, we want to first check to see if the avatar is currently stumbling. If it is, we'll just return. We don't want to trigger a new stumble animation or a new action. So if our avatar is not stumbling, then we want to set isStumbling to true because we're about to trigger a stumbling animation. Finally, within our set timeout, we want to set another timeout here. So since it's taking 1 second to fade from the stumble animation into the wave animation, we're going to set isStumbling to false or back to false 1 second after this code gets called. So that'll ensure that our player is completely back into the default animation before we allow them to trigger a stumbling animation again. So now if I click on the avatar once, it triggers a stumble. I'm clicking again and again and again, nothing's happening. Now we went back to the wave action and I triggered that stumble again. So we're no longer getting that weird bug of the avatar going back to the T-pose and triggering multiple animations. So I hope you found this tutorial very helpful, whether you're trying to spice up your developer portfolio or you just want to add a model to your website and animate it. So thanks for watching, and if you'd like to see more videos like this, be sure to hit the like and subscribe buttons so I know that you're enjoying this content. Until next time, take care everybody.